Good afternoon, everyone. This is the relearning for identifying features of a graph. This video is going to walk you through the key points. You should have your worksheet that I gave you in class out while you watch this. And then there's a graph for you to do after we've done one together. So you can fill this out on your guided notes. So the title, we want to make sure that this title is scientific. It's not fun or eye-catching. It simply explains what's being graphed, not like an English title. Remember, your x-axis is this horizontal one here, the one on the bottom, and then the y-axis is the vertical axis. And then what we need to make sure, I think most of you who are doing this relearning missed the scale or made a mistake on the scale. And the other thing you want to make sure that you put on both axes are your units of measurement. You also want to make sure you recognize when you're looking at the data table, what is the independent variable? Something's not affected by the other variables that you're measuring. So that could be time, years, age. Those you're going to graph on the x-axis. And this makes the graph easier to read. You may run into graphs in the future where the independent is not on the x-axis, but we're going to always put that on the x-axis. The dependent variable is what's being measured. It depends on the independent variable, or we're seeing if it does depend on the independent variable. And that could be something like distance, depending on time. The number of cell phones could depend on someone's age. And we're going to put that on the y-axis. If at any point during this video you need to pause it to finish your notes, go ahead and do so. So when we need to find an appropriate scale, we're going to take our largest data point. Excuse my typo there. There should be a T after S. You're going to take your largest data point by the number of boxes you have, and you're going to round that up to the. And I don't simply mean round up to the nearest whole number, but you want to round up to the nearest number that makes sense to count by. So counting by 16 probably doesn't make sense. So if you're rounding 0.75, you're going to round that up to 16. That doesn't really make sense. You probably want to count by 20s. So let's do a practice. Excuse the volleyball players who are making noise in the background. I don't know if you can hear them. If any of you are listening, your voices are recorded for eternity in the background of this. All right. So you should have this on your worksheet, and here is a data table showing me driving in town. And the top row shows minutes, and the bottom row shows distance. Take a minute and label your independent and dependent variable. Grab a new pencil. So if you said that time is independent, you're correct. Time doesn't depend on anything, especially in this case, time just keeps ticking. And distance is your dependent. So we're going to put time down here, and you're going to put distance over here. And you're going to want to make sure that unit ends up here as well. And then you want to make sure you add in a title. It could be something as simple as driving distance over time. Okay. Now we want to make sure that we're going to count our boxes to figure out our scale. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So there are 20 boxes. And you're going to go for time, and you're going to go to time and look across, find your highest number, which we look across and we find that 20 is our highest number. So we're going to take our highest number, 20, divided by the number of boxes, 20. So I gave you something pretty easy. So every one box is going to equal 1 minute. So we're going to go 0, 1, 2, 3. We're going to label our x-axis. So go ahead and label your x-axis. Now we're going to do the same on the y-axis. I should have given you harder numbers, but if you look across here, you're going to find your highest number. Your highest number is not 13, even though that's the last number. Your highest number, again, is 20. Let's figure out if we have 20 boxes again. 1, 2, 3. So we got 20 boxes divided by 20. So again, we got 1 box equals 1 kilometer. So Ms. McConnell took it a little too easy on you. I should have made that hard. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And I almost forgot to label my 0. Okay, last thing we need to do is we need to plot our points. One of our commonly missed data points was 0, 0. It is important in the story that this graph tells is that I started at point 0 at time 0. So, and then at time 5 minutes, I was 2 kilometers away. At time 8 minutes, I was 10 kilometers away. At time 12, I was 16 kilometers away. Time 15, I was 20. And at time 20, I was 13. And last but not least, this should be a line graph. So we actually need to make a line. Do not need to use a ruler. Drawing a relatively straight line is fine for this. All right. If you have questions, please come and see me. Otherwise, you should do the practice part, practice 2, practice on your own by yourself, graphing Harry Potter's movements. All right. Thanks very much. Have a great day.